good fort going, and I lost it just a couple hours ago. I should have been streaming, but I guess I just wasn't. Bronze Colossus destroyed me. Would have made a great video. Oh well. Oh. Oh. No flux. Damn. um. Yeah, this looks promising. Oh, what? I don't even remember looking. What the hell? Yeah, this looks good. Oh, this is near a necromancer too? Jesus. You know what? Fuck it. Probably gonna die, but let's just accept that now. Okay, this is relatively flat. That's pretty cool. Alunite. Haven't hit any water. That's pretty cool. Okay. Galena. This is gonna be one of those sites that doesn't have big coal, isn't it? That might be bad. Native copper. Yeah, I don't usually see that on. Yeah, this isn't a sedimentary layer. God. Well, and we're near Necromancer. Well, well. always the first thing I end up doing. Okay. Damn. Bunch of rotten fish. It's too bad. Should designate a dump, I guess. Oh yeah, it's cold. spelled. Dude. Sure hope I get migrants soon. It's just like silent.
And hello, today in the workshop I've got a PV amplifier. This one's 4000 watts. This is a bit of DJ equipment that's had a bit of DJ abuse. Let's have a look. And like most professional amps, there's not too many controls on the front. There's more controls on the back. We've got some hidden little switches. The switch is where you set the mode, so this one was set in in parallel. Wow. Someone wanted to get the very maximum power out of this thing. Just going to power this thing up using the restricted power supply, never mind the wiring. Well, there's lights on that shouldn't be and lights not on that should be. And there's also a horrible burning smell coming off here. Oh crikey. We'll turn that off. There's a lot of screws on this as well. Hooray! At least they're little self-tappers, which come out quite quick. And then this bolt out here. Bizarrely I'm having to use an 11mm socket. It's not a 10mm. I don't know what size that is. Be some imperial thing I'm too young to know about. What will we find inside? Oh, this has had a bit of trauma in its past. Oh, look at that! Huh. It's a former patient to this very workshop. Last in good 3 years ago. I have to look up what happened last time. But I am seeing blown up parts. These inrush themistors shouldn't have big chunks missing out of them. Yeah, something's seriously wrong with this. Well, as I've had this before, I've probably marked up all the connectors, so I think I can just start yanking them out. Did I mark them? Oh, at least I'm filming it. Pull the mains cable off. There's just a little earth tag down there to release. Get the screw, don't want to lose that one. I think this board's only held down by 3 screws. Oh. One that side, this one on the right, and right in the middle of all these caps. If I remember rightly, this board won't come out with the transformer in the way, so I'm going to take it out. But it's really heavy. They weren't thinking about me when they designed it, were they? Anyway. Oh God. Oh, now I've got the awkward part now. I don't want to let it completely go. Just got to balance it right on the edge of the desk. Ooh. This bolt feels very long. There goes the washer. That can at least wiggle a bit. It might lift it out. Well, let's disconnect this cable tie. Right, disconnect. I mean chop off. Let's pull this out. Oh, I didn't pull it by its wires, did I? Yeah, don't do that. The board's held in these little like key-shaped things, so in theory you just pull it towards you and lift it by the handles they haven't provided clearly, and it still doesn't want to come up. This board's just trapped by everything. These bits of card, these air sort of guides, even the main switch is in the way. Well, not they intended when they designed this. You have to just... Surely they don't want you to bend it. Oh, there we go. Crikey. God, are you supposed to do this? Oh. And this is an amp I've had apart before. I don't remember struggling this much with it. Well, it's all very dusty as normal for any DJ equipment, and fluff stuck in the heat sinks. I'm going to take these heat sinks off actually because I can't really see a lot of this at the moment, and they also have quite a lot of weight on there, so I'm very worried about this board just folding in half and snapping. That'd be a bad day. And of course, all torque screws, which, to be honest, are a better screw. Wish I had some sort of Jedi powers to make screws disappear. Well, I'm pretty sure everyone watching this knows that that's not a good sign. Yeah, it's not just Han Solo who's got a bad feeling about this. Well, you can sort of see where the blasters come from is under this heatsink. And it looks to me like the legs might be blown off that transistor. Well, I don't know if it focuses on these bits under there. It's not just the camera that's out of focus. I think the world underneath here is out of focus, really. I'll just take them both off because I might need to read the part numbers off these ones. Oh, well, it does have all of its legs. Yeah, it is definitely blown up though. I'm not a fan of this layout, lying face down. I mean, I get it, it's all low profile and makes the amp nice and flat, but what a nightmare. Nightmare to work on. And all this heatsink compound everywhere. It's really messy to work on, so I'll have to clean that off. I can tell you, if you get this on your clothes, it doesn't wash out. Okay, let's start assessing the damage we can see. These two things are IGBTs. These are transistors which switch the levels to the output transistors. They're a bipolar transistor with an insulated gate, however that works, but you have the gate here, then the collector is on here, then the emitter. This should be open circuit, and it's short circuit, dead short, which is not a surprise with this burnt leg. This other one looks alright. Okay. Yeah. And we can also check these diodes here. That's a good one. And this one. Yeah. Those bits are fine. The output transistors are actually all in parallel, so you can actually you can just check across them all in one go. So from the collector to the emitter. Yeah, this one's fine. This whole set will be fine because of that. And same here. Collector to emitter. Actually, I better unsolder that shorted transistor because that's going to really confuse all the readings. Lively. I didn't expect that across a shorted transistor. I got a discharging tool, which is a good thing. I should remember to use it. Oh, decent voltage there. Anyway, where were we? After that bit of excitement, we're just lifting this out. Now that shorted part's been removed, I can check all these transistors. Now on these, all the collectors and the bases are common. So we got, that's the base, that's the collector or the tab. So the emitters here need checking. So from this one, that's a good one. This is good. This is good. Also good. That half looks fine. So we'll do the same here. Between this and the emitter. Oh, the emitter's this side. Well, they look okay to me. Just have a general poke around anything that's lying about. This regulator here. Oh, seems a bit odd. That's knackered. Let's take that regulator out just to check, because it could be a short across something it's supplying. It's a bit warm. So if we start labelling up the schematics and just mark on what's damaged where. So Q131 went short straight across there. So that's the first problem we've got. And I also found out a regulator, which is IC203, which is probably not on this page actually. I think it supplies a low voltage rail. Yes, down here, IC203. That's damaged. But from what I can see, IC203 drives the fans. How strange. I wouldn't have thought that I'd had anything to do with the problems this has got, but maybe. If it's got too hot and no cooling. Just check the one for the other fan. It's across there. Yeah, there's no problems here. That's a proper reading, that is. Just have a poke around the circuit that drives this blown up IGBT. Part of it, there's this Zener diode here, which is fine. Well, it appears to be okay. Let's check some resistances. 22 ohm resistor. It's spot on. What's this supposed to be? That's not how you measure it. 4.7k, yeah, that's fine. This capacitor here, just check that's not shorted. 1.2 meg. Yeah. You tend to find with these things, when the surface mount resistors go, you can see it. Like this one here. This one's got a blister on it, should be 2.2k and it's measuring 1.8. Really? 1.5? Very close to this transistor here. That looks alright. Oh, 2 ohms. It's not alright. Ah, right. Let's write that one down. Q102. Q102 is here. And those resistors, the 2.2k, that's blown as well. So, I'm starting to get a picture of the damage actually as well. I'll get the hot air gun on this. Get rid of these shorted parts because, like I say, they throw all the measurements out. And this will probably take a while to come off as well. Apart from that one, came off rather easily. Just check what size resistor that was. A handy little tool. I think it's a 2512. Oh, no, it's smaller. 2010 maybe. So just start marking some of these parts on the we tested as good, so that diode was good. All this round here is fine, which makes me think that whatever caused it might just been just overload, and may just be something connected to the speakers maybe that shouldn't be. What about this diode here? Yeah, if that's gone, that would have taken that out. D197. That's just down here. 0.4 volt drop. Yeah, it's alright. I should check out where the minus 18 volt supply comes from, because it may have been damaged. The minus 18 volt rail comes from IC303. Where's that? Oh, down there. There it is. Bit awkward to get at. I'll just check for obvious shorts initially, just to... It looks sensible sort of measurements. Nothing looks burnt up around it either. Yeah, I think it's okay. Oh, hello. Cap's missing. Where's that gone? Yeah, that's never a good thing. What's that? C404. It appears to have fell off the board, and it's close to this rail. Just referring back to the drawings, I'm just... I can't see a correlation between a short circuit over here just finding its way to damage this. Not straight away, if none of this is short. What could it be? Maybe if I follow it from here, so if this hasn't damaged that rail there, or that one there, it looks okay. Maybe we've got trouble here. So this IC100, where's that? And of course what we appear to have is, there's a channel here, channel B, channel A, and then all the controls are right on the edge over here. So we'll spin this around. Have a closer look. And I see burnt resistors right next to IC100. Oh, these all look a bit dicey. Oh, and over here. Yeah, I think I'm going to move to the other bench, because this is getting a bit small and I need the microscope. Here's IC100, and it's got some damaged resistors. I think this is where the energy went. Yeah. Yep. That's gone. That's gone. That's got 8 meg, blimey. Completely gone. Back up here. Yeah, that's gone. What's this one? That's okay. This chip contains 4 transistors, and I'm going to say that they are absolutely goosed. More worryingly, they sit between 2 more transistors, which are over here. Let's have a shufty across. The transistor array is suspended between these 2 transistors here, and I can see burnt resistors again. Yeah, they're also knackered. So these transistors, I think, so that's base, collector, emitter. Are they short? That one looks like it might be okay. And this one is 2 ohms. Yeah, that's knackered. Which one's that? That's Q105. Well, now we've established that, might as well remove these dodgy parts off here. The hot air gun, weapon of choice. I can just see the old flux starting to bubble up. This may be exactly what happened to it 3 years ago when it first died. That's off. Whilst the board's hot, we'll do the others. I just took that one off, there's nothing wrong with that resistor. I'll desolder these 2 as well. Got holes blown in the tops of them, look. You can see little dimples here, or you could. Like there, where the meter probes went in. Patience is needed. There we are. Let's get these big transistors off next, so just move that out of the way. Right, to get these off, I'm just going to sort of flood them with solder. Warm all the pins up together. There we are, comes out nice and easily then. Same with this one. It's getting a bit too hot to touch. Might be better off just cutting the legs off it. He's going to mess me about. Just fish the legs off. Clean the holes out. Oh, that didn't work. Oh, we're having a bad time here. Got a bit of pad damage there. Yeah, have a look if that matters. Probably be okay. Tend to find if the pads just peel off that easily, they don't actually connect to anything. Just going to assess the pad damage now. Just clean it up. It's difficult to see with the black solder mask. I'd almost feel paranoid that they do this deliberately to make repairs awkward. What we got is here. That's fine, that's connected to there, and this one's all good. That pad's there is fine. This one here is half intact to there. This one, it's smooth as well. This doesn't go anywhere, so although the pad's missing off the top, it's not a problem. Unless it's missing from the bottom as well. Yeah, there's two pads ripped off here. Fortunately, it's the opposite way round. So, yeah, it is a bit chewed up though. That one's a little bit, yeah. The through-hole plating's still intact. Now that's encouraging. We've got away with that. Just be a little bit awkward to solder. Just focusing back at Q131, which is the IGBT transistor that blew up. I can see why it didn't take any fuses out. It's because the track's blown off the board. I'm going to clean that up a bit. It's pretty charred and ruined. Some of the carbon that comes off here is conductive. If the voltage on here is high enough, it might travel across this carbon residue on here. Definitely a problem with old like monitors and HT circuits. Yeah, you can see here that the track has acted like a fuse and disappeared. So I'm going to have to scrape away a bit of the solder mask, this black part here. Try not to tear it off the board. Just going to clean that up with a fiberglass pencil. She's very good, but it's a dreadful tool because you get little bits of fiberglass that always end up stuck in your fingers. But that has cleaned that up beautifully. I'm happy with that, so we can look at some sort of repair on this. Looking at this other pad as well, just to see that it's in good condition. Might need to perversely add a bit of solder so I can remove it. That's nicely tinned. Find the desoldering tool. Oh, this doesn't work very well at all, does it? Fortunately, the centre pin of this transistor only goes to the top layer of the circuit board, so I only need to repair the top, because I don't actually know if the wire is intact or not, but it doesn't matter as long as we're aware of it. To fix the top track, I'm going to use this copper tape and cut a shape out that sort of fits and stick it down, then solder it on and hope it holds. I'll put a little dot where the hole should be. That's about it. Then I think I'll solder it on first. I'm just going to stab it with this. There we go. Now that's about it really. So I have the new transistor, and here it is. I'm just going to slide it in there, make sure it sits flat and that the hole lines up. Let's just check that. Be a disaster if I got that wrong. Yeah, that's okay. That's okay. Let's go for it. I'm going to do the end pins first because they're not so delicate. I'm going to push that back a bit. It won't hurt to get extra solder on here. I'm sure you can hear that helicopter flying overhead. There's actually an air show on today. I live about, I don't know, 5 miles away from Cosford Air Force Base, and they are doing the air show. First one in 2.5 years because of the pandemic. And it's right up there. Yes, looking again at this area where this 2K2 resistors burnt up, but the underneath the board's actually burnt as well. It's not burnt this side, but it definitely goes underneath there. So I'm going to fetch that perfectly good resistor off, just so I can check the board underneath. Yes, it is a little bit charred. Well, that does not look brilliant, especially with the pads twisted around like that. That's definitely not ideal. Sit back down. The black solder mask makes you think this PCB material will actually be black, but I don't think it should be. It's like typically be a light colour, so I think this is charred and probably conducts a bit of electricity. Yeah, so this blade, I'm going to put some, see if I can dig out this charred mess. I think that may be it. I think what I'm going to do is use some epoxy resin to fill the hole in, really. Like a pothole repair. If it will flow nicely, I'll give it a dab. I'm not that patient. If I get this right, it will stick the pads down as well. It's difficult to tell if I've got this level or not. In fact, no, I haven't. No, it's not level. Dig a little bit out. Hope it flows back, because this thing's going off all the time. It sets in 5 minutes, so yeah, let's not faff around here. If I can bend that back down, just to touch it but not push it in. I should probably leave well alone right now. Okay, we'll go with the little transistor. Just tack it on there. Right, whilst I leave that in to dry and do whatever it's going to do, we'll move on around the board. So the next part was the capacitor that fell off, and God knows where it went, it's vanished. I've got a new one here, so I'm going to just fit that. I was going to clean these pads up, put some fresh solder on. Just give the area a bit of a clean. Fresh flux on there. We'll see how it sits on. So we'll just go in with the iron. Set that sink down. Still working around the board in a clockwise direction. We're now on to replacing some burnt resistors. These are little 1206 size surface mount ones. There's much smaller ones, but these are still a bit of a faff to fit. Or at least getting them out the packet is always fraught. There we go. Tip them out. We'll keep them safely nearby. Put them the right way up. It doesn't bother the electricity which way up they are. But it bothers some people, I tell you. So, like always, bit of fresh solder on there. Just a little bit of flux, and we'll just tack these on with the iron. I don't care which way up they are. And where's the other one? Over here. So Q105 at the top there with the dodgy pads is a 2SA 1837. One of these. It's worth checking if these transistors are real, because they're obsolete. With all the stuff going on in China at the moment, you end up getting these things on eBay, which is always a little bit iffy. There's a lot of genuine businesses on there, granted, but you never quite know. So these things are rated for 230 volts, 1 amp. I'm going to see if they can actually handle what they say. This machine's heading on for nearly 60 years old now, but it's very useful. It's a Tektronix curve tracer, which is basically a lie detector for transistors. It certainly sniffs out any fakes. So to use this machine, we put our transistor in the test socket down there. Just pushes in. And we simply turn it on. In this test we're going to look for the breakdown voltage. So turn it on, see how we go. So that's 50, 100, 150, 200, well, 250. This is supposed to be good for 230 volts and it hasn't broke down yet. We'd know if it had because the line would go vertical. If I carry on we might encounter that. No, we found the limit there. I'm happy that this doesn't have a problem with the breakdown voltage. Just going to fiddle about some readings. I want to do another test on this and just see how it works. We can put a few steps on there, say 5 steps. So pull that out and it's 2.2. Drive a bit more power now, up to 10 watts in there. A bit nervous about blowing it up on the test bed, but there we go. Then we have the sort of typical curves you might get off these things. This is looking quite genuine. I mean, we're only driving this at about 25 milliamps at the moment. It's rated for 1 amp, but you know, we're also driving this up to, you know, this is now 200 volts across there. Well, there it is. Yeah, there's a bit of heat on there. So that one, I believe, is genuine. So we'll try its complement, the 2SC4793. Just pop that in the test thing there. This is an NPN transistor, so I'm going to swap a few things around on here. To start off, we've got to go NPN there. Then we'll have to uninvert the display. Uninvert that. Now it's good to go. Let's give it the test then. So we're going to go up. So we've got a 20, 40, 60, 80, 100 volts, looking good. 120, 140, 160, 180, 200, and then it goes off the screen there. There's 220. Yeah, there's nothing wrong with this one. This is also looking pretty healthy. So, I think these are genuine. So that'll sit in there. And this one sits there. Well, there's only one pad on this one here. So we've got that one. There in. To solder these from the top because the pads are missing off the bottom. Right, solder these resistors on. 510 ohms right at the top. Yeah, get both ends in. Another 510. Now a 49.9 ohm resistor. Strange value. And there's 2 of them. Needs levelling up a bit. I'm just going to dip the chip on top of the flux just to get some flux on the chip's legs. Then I'm going to go with hot air with this one. Some of these pads are connected to ground and all the heat gets soaked away. Can take a long
Hey,
time
JJ
to
King,
heat.
how's it going? Nice. Just
And here's a resistor
I
to
started
see
this
on top of the
fort
pothole
in
repair.
winter, so I missed the first wave of migrants. I've been at this for like a
Where'd
while
that go?
now. I'm still population of 14. It's kind of slow going.
Little bit of flux. Let's get this on. Nice and easy. Big resistors solder on quite nicely. Lovely. Let's neaten that up. Oh, oh no. What have I done? And here. Oh, what is wrong with me? Come on, sit straight. Up that in the board. What's next? Oh! A few too many. We only need the one. It shall have its leg bent. Something like that. it's about time for some heat sinks to go back on, so just put a bit of heatsink compound on. Just checking there's no sort of damage on here. Looks okay. This heatsink compound's terrible stuff. I'll try not to touch it. There's probably a special tool for this, but I ain't got one. Board flipper, turning over, I don't know.
Okay.
Make sure I put loads on for the next guy to get all over his top. Check out my alignment here. There's a lot of screws here. Well, I think that's ready to try out now. It's a difficult to handle, it's a bit bendy. Just trying to line these up all over the boards and just give it a
That
little
felt like a quick winter.
push.
Hopefully
That's locked in.
more dwarves
Oh,
show
only
up this
a few
spring.
screws to
If not,
put this in with.
I'm gonna be going crazy.
It's about the only part of this amp that's quick to do, I think. One right down in the centre. Whew. There's this bolt that holds this transformer in, so I'm going to pull it back over the bench so you can get to the bottom. There. Let's give it some inputs. Maybe a bit premature now, but see how this amp runs?
Oh yeah, you're right.
So, here it goes. Oh look, there's output on both channels. Well, that looks prepared now, doesn't it? Well, that's good enough for me. Put it back together now. I'll put the lid on, but just checking that it's got these insulated cards on there because they're needed because the heat sinks are actually the output on this amp. So if you didn't have the card, you might short them out, which wouldn't be very good. was a really irritating repair in the end, mainly frustrated by a lack of parts. Just a world we're in now. Catch you next time.
I wonder why he's pissed off. Why are these seeds here? Seeds go up here. Whoa, what happened to this? Got destroyed. I don't even remember what was there. I think it was oats. Oh yeah. Crap. Forgot that I bought animals. Shit. Should have released them a long time ago. Oh yeah, the water buffalo starved. Shit. Oh, this could put a different video on. Oh, cool. Here we go.
And this time in the workshop, it's a bit of 1980s computing nostalgia. This is the Sinclair Spectrum Plus 2. This model was released in 1986 and was actually made by Amstrad, and internally the electronics are the same as a Spectrum 128. Only this one comes with a new case with nice clicky keys and a built-in cassette recorder. And not loads of things at the back. Power supply, expansion I/O, which is an edge connector. Then there's a serial port, external keypad connection, RGB monitor outlet, RF tuner and sound. It's also got a pair of joystick ports on the side, and very usefully, a reset button. When I was a kid, we had the 48K rubber keyed Spectrum, and there was no reset button on that. We had to pull the cable out the back. Now these are powered from a 9V DC power supply, which has a sense negative connection, so we have to plug these in backwards. We connect to the RGB socket for our monitor, and the sound output there. And there's nothing. Oh, no power light, no display. It's not even drawing any current, not even a milliamp. This thing's dead with a capital F. We'll pull all these cables out because it needs to come apart. We'll flip it over because the screws are underneath. Be careful not to tear these ribbon cables. These are for the keyboard. It won't work if I break them. We'll unplug the tape deck as well. And that reveals a fairly busy circuit board. We've got an RF modulator, quite a few Amstrad branded chips. And here we got the 3-channel sound chip that appeared in the 128K version the first time round. Now this chip here now sports a heatsink, which it didn't do in previous versions. It's known as the ULA, which is the uncommitted logic array, which doesn't really give you much clue as to what it does. It takes a lot of load off the CPU. It's really the key to the performance of this computer, which was really pretty cheap in its time. Then we've got the read-only memory, the ROM. This is the famous Zilog Z80 CPU. And this Amstrad chip here is actually a memory multiplexer, which is used to split the CPU's 64K address bus between 128K of RAM chips and various other peripherals. And down the side here is a computer's power supplies. And at the heart of this are this 7805 voltage regulator, which looks like it's been replaced to me. Looks a lot newer than everything else, which have got 1986 date codes on every single part. Yes, what does this one say? It's a bit hard to read, but I can't see any reference to 86, and that heatsink compound looks quite recent. So I'm not the first person to find out it's got some sort of power trouble. So we'll plug the power back in so we can measure. I'll pick up ground off this tab here, check the input, and we got 0.35 volts. And obviously nothing coming out. Yeah, let's check it at the socket. Still no good. Have we got it coming in? Yeah, there's our 9 volts. What's going on? I'll just unplug that and see what's going on underneath this board. So that can come out as well. We'll unplug that. Oh. What's going on? Oh. I hardly touched it. Let's whip this out. Let's have a look. Well, the DC jacks had a bit of attention off someone soldering iron, but they all appear connected. And there's a lot of solder flux around this joystick port. Oh, and solder. Very blobby. And I can see the odd bit of rework on these RAM chips. Not a lot, just the odd leg. Let's put the power lead back in. And we're still drawing no current. Look at that. If I measure the voltage on here, 9 volts. Fault must be at the top. But now I'm questioning this socket here. Something suspicious. Although this pin's soldered at the bottom, there appears to be nothing here. I think the board's been damaged. Well, that's easily checked. Pull that out. Let's resolder it. Let's put the regulator back on. Plug back in. Let's try that now. Oh, we got current. 0.8 of an amp. This is encouraging. Let's check these voltages again. From the tab to the input. There's our 9 volts. Nearly anyway. There's our 5. This is good. Let's poke around here, see what we've got. Minus 12 volts. Plus 12 volts. What's here? There's minus 5. Good. Now that's really encouraging. I'm dying to try it now. See if it works. There's a monitor socket. And the audio. Oh, that's not how it's supposed to look. I thought I might have fixed this, but there's more to go at. On the positive side, we got a video display, so a lot of this is working, especially this chip, because that would be a nightmare if that's gone. A good place to start is with the CPU. Now this is an 8-bit computer, so there's 8 data bits around these pins here, and it's got a 16-bit address bus around here. We're going to probe them, see what's happening. And we're definitely going to need the oscilloscope. And put a scope probe on. And move the position down just a little bit. Spec seems to be looking at 5 volt waveforms. And for convenience, I'm connecting the scope round to the negative rail of the power supply. So if I refer to the service manual for this computer, find the schematics, we can see an 8-bit data bus runs all the way across here, and connected to it is stuff like the joystick port, the ROM chip, both banks of RAM, and into the ULA. And there's a 16-bit address bus, and this is connected to a lot of things as well. Directly to the ROM, to the keyboard of all things, and the memory multiplexer chip, whose output goes to the ULA and one of the banks of RAM, and a second bank of RAM is here connected directly. When it's switched on, the first thing the CPU does is look into address 0, which is actually wired to the ROM chip. So it actually looks in address 0 and has a look for an instruction, and then it just moves from there, just counting along. So when we probe the data bus, we should expect to see lots of activity on all 8-bit lines. And similarly on the address bus, but maybe not all of them, because the computer appears to be stuck, doing nothing. The data bus starts on pin 15, so we go 20, 19, 18, 17, 16, 15. There's our first bit of data. Looks pretty busy. There we go. Next one. Okay. Still there. Okay. Then we got the 5 volt power supply. Fine. More data, good. Also good. Yep, plenty going on. There we go, okay. Then we get to the clock. Bit fuzzy, but it says 3.55 megahertz. That's absolutely bang on. Then get onto the address bus. This is address 15 and nothing happening. 14, still nothing happening. 13, no. 12, 11. No data there. No activity on the upper address bus. So over here we've got address line 10. Nothing on there. 9. 8. Ah, now we have something. Okay. And nothing on address pin 7. 6. Alright. 5. 4. 3. 2. 1. And finally plus 0. There we go. A good idea to probe the output of the multiplexer, because this is where the RAM chips are connected, and the ULA, because it is displaying random junk. Okay, pin 1 row address select. There we go, we've got data there. Pin 4, that's DMA0. We've got data, brilliant. In pin 7, also good. Pin 10, more good data. This is looking quite good actually. 11, 12, 13. Also good. Pin 16. Beautiful. Pin 19. Lovely. Then we find pin 37. That is address line 15. That's low. Then down to 33. It's at 6, 5, 4, 3. This is memory address 0. Looking okay. Memory address 1. Memory address 2. Memory address 3. Memory address 4. Memory address 5, memory address 6, all good. Memory address 7, oh, low. Pin 25, that's TS2, that's low. Pin 24, TS1, also low. Then we've got DMA6, got data on there. Well, that's all the outputs checked. I'm pretty confident that the memory multiplexer is working just fine, and I think the CPU is, but you can never quite be sure. It's certainly cycling and doing stuff. But what is of interest as to which memory address lines are not being used, and it only seems to be accessing the first 383 lines of memory, which is all in ROM, none of the RAM at all. Now I do have a spare CPU, and it's got OK written on the bottom in my own handwriting, so I reckon it's going to be OK. Because it's socketed, it's going to be easy to change. But I will turn the power off before I do this. But I do this natty little tool for pulling these out. Saves bending the pins. Just line the legs up on the back row. And press it in. Power on. So that's made no difference. That sort of eliminates the CPU. But it could be a bad ROM. Now, I've got a diagnostic cartridge here which has its own ROM on there, so we can see if it boots off that. Just pull the power lead out first. Get our cartridge. Push it on. Power back in. 4 lights is a good sign. All the power supplies are there. But that's not booting either. Something quite wrong with this. I'm going to pull the ROM chip just in case it's that, or at least it's causing trouble. Put the power back in. Oh, we have a bit of a flashing code there. That's pretty much a red border. What does that mean? Although reading the manual for the diagnostics cartridge tells me that the red and black border means the ROM has failed. You're not kidding, it's missing. Okay. And the elephant in the room, the ULA, I'm hoping it's not, because I don't have a replacement available. Just going to probe some of these logic chips. So here, this is a 7404. We've got a lot of high-speed data going on there. Same here. Yeah. This all looks pretty good. What's this one? That's just sat high. So this one should be low. Which it is. And that's ground, that's the power supply. And on this side we've got the power supply. That's 5 volts, that's okay. So here we've got, oh, what's that? 2 volts. That's low, okay. Also low, this should be high then. And it is. So this one low, so we should have a high there. Okay, one dodgy input or output. And right next to it is a quad multiplexer. This is a DM74LS157. Check this one out. Got data on that pin, looking good. Sat low, okay. Also sat low. Low again. What's that? Low-ish. Oh, another one about 2 volts. Okay, that's high. And that's probably ground, okay. So we've got the power supply rail, 5 volts, that's healthy. Then what we got, low, funny floating voltage, another funny floating voltage, then that's high, low, 2 volts again, high. I'm just going to whip this chip out and change it. Just pull that out of the way, so I can just flip the board over. Flip it back over again. Let's pop the new chip in there. I say new, it's as old as the original one. One over here. Put the regulator back on, but it won't work. Let's see what that does for us. Well, it's different, but still not fixed. Now we've got a stripy screen which looks more like a memory full, quite a serious one, but I think it's different every time I reboot it. I mean, check this out. You can see what I mean. Bit of a tricky one, this. Now, after a slow process of elimination, it's looking more likely that there's bad RAM in this computer. Now, you can put new RAM just on top of it, as long as the chips aren't shorted. So I'll put the thermal imaging camera on and see if there are any hot chips. Plug the power back in so it does warm up. Let's get the camera over this. See what we see. Well, that's the core of the CPU warming up. You'd expect that. All these other chips are all glowing away. Nothing over 29-30 degrees. You can see one bank of RAM chips there at the top. And underneath is another one there which are a little bit colder, but none of them stand out as being hot. So there doesn't appear to be any short circuits on the board, so we can try some RAM piggybacking. I just need some RAM. I've got a whole board of them here, some 84 of these chips. I just need to desolder them. This is the 256 kilobyte memory card out of a Plessey computer, apparently. Now, there's probably someone in the world really desperate for one of these, but I'm going to use it as a parts donor. Let's use the soldering tweezers on these. Get all the pins in one go. That'll do. If anyone's wondering, this is the Metcal soldering tweezers with the PTTC 706 cartridges in. Very handy. The idea is that you simply just push the chips on top of the old chips. The premise being that if they failed open circuit. There we go. It's got 256k now. Now, of course, you can't actually address 256k, but it gives the keyboard warriors something to comment about, doesn't it? I wouldn't say that's much different. No good. So they can come off. I don't think that's made any meaningful difference. So we changed the CPU, that didn't fix it, we've eliminated the ROM chip. I've also checked out the RAM, that seems all good, but this seems seriously not booting. Now I do remember scoping the address bus, and I did see some pins that are just stuck low. Now, I assumed that they just weren't being addressed because it wasn't booting, but I'm going to check them out a bit more. I want to verify the data bus is working again. So that's pins 7 to 15, well we started 15. There's first data. X1, good, good. That's the 5-volt power supply, that's normal. More data, 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 and data. So importantly, it's hitting 0 volts and pretty much 5 volts, so that's working fine. Pin 6 is a clock, 3.5 megahertz. That's fine. You can see there's some interrupts going on there, so that's encouraging. There's a lot working on this, despite it not booting up. So now we've got pin 5, which is address line 15, and that's actually working. Okay. Pin 4. I'm not so happy about the high side of this, a bit low, but it is switching. Again, that seems okay. This is address bus 12. Pin 1. Oh! Now, I didn't see that before. That does not look very healthy. We'll check round here again. This is address line 10. That's okay. Address 9 is also good. Address 8, good. Address 7 is fine. Address 6, 5, 4, 3, 2, 1, and then address line 0. Fine. Well, I completely missed that before. When I checked first time, there's quite a few pins just sat low, whereas that one's now stuck high. Something's changed. I don't know why. So we'll check the resistance from pin 1 to ground. 220 ohms. That don't sound good. If I compare that to the pin next door, 41k. Something amiss there. Go back to the 5-volt supply. Oh, we found the problem. That's definitely not right. Check the pin next door. Yes. Okay. So, although there's address buses all over the place, we can concentrate on this part here. It doesn't appear to be on the output of the address multiplexer. So A11 goes from the CPU to the keyboard, which isn't connected, so we can ignore that. It goes across to pin 15 of the multiplexer chip. And it also goes to the ROM, which we can ignore because we've already taken that chip out and replaced it with a diagnostics cartridge. But A11 is also connected to pin 9 of this joystick interface chip. We'll check that out. Okay, from the 5-volt supply to pin 1 of the CPU, 14.7 ohms. Okay. So pin 15 of the multiplexer, so we've got 19, 18, 17, 16, 15. It's 14.77 ohms. That's actually getting higher resistance, getting further away from the short. And pin 9 of the joystick interface. Oh, 14.1 ohms. It's that. Probably. Now this is a 22 pin chip, so I need to change the tips on my soldering tweezers. Now these are pretty big. They're going to take quite a bit of power, these are. Type of station.
We got a breeding pair of yaks. That's pretty
Pull
good.
these ones out. Bigger ones in.
Oh. Oh.
So has that got rid of our short? Yes, it has. But will it boot without the joystick interface? We'll find out. I can't catch a break with this. There's more faults. We're now entering the stage where we're going to play chip roulette. Which one could it be? Could it be this? Its main job is to generate the sound, but it's also got some I/O functions to do with the keypad and RS-232 sockets, so maybe not. I don't think it's any of the RAM chips, because when I piggyback the whole lot, nothing really changed. And I'm led to believe that most RAM faults are of the open circuit nature, so that should have fixed it. I didn't think it was the memory multiplexer chip either. Those black and white bands does make me think it might be a memory paging issue. I think it's time I bit the bullet and took this chip out. It's looking more and more likely, despite what I thought. It's going to be quite a long job removing those 40 pins, so I'm going to unplug these cables and connectors. I think the nozzle's a little bit blocked. It's not behaving very well. If I can get the cleaner in. Okay, out you come. Oh, I'm surprised he came out that easily. I should clean these holes up before I forget. I don't have to desolder that chip again if I don't have to, so I'm going to put a socket in. So quite cheap. Yeah, might as well put that in. Let's do the corners first. Just make sure it doesn't just fall away halfway through soldering it. I'd like to put a socket on here, but it's 22 pins, which is not that common, but it's a wider spacing. So I'll have to build a socket out of bits of sockets. There's half a 14 pin, and here's half an 8 pin. That'll be fun to solder. Just try and stick it down with this. See how that works. Hopefully it's all still straight. Looks okay. Might as well put the board back in now. It's not going to be soldered anything on it anymore, hopefully. Well, here they are. They've been sold to me as new old stock. I have no reason to disbelieve them. Oh, move that. Although I will just pop them in the leg straightener just to make sure. Just try and line the legs up on the back row first. Don't anything to bend. There we go. Let's plug some of this back in. Let's plug the ROM cartridge back in. So I haven't got a normal ROM in it yet. And of course the power. Oh, still not right, but it's behaving differently, and it's clearly executing some sort of program. And the border's flashing a lot. We've had red, we've had flashing red, and now we've got green. So it certainly appears the memory multiplexer did die on me, and now it's been replaced. It's back to behaving how it was. So it's not this. That's been replaced. I'm starting to have to accept that it could well be the ULA. I've managed to borrow one. So I've got to get this one out of here, because it's such a long chip with a heatsink on. It's difficult to get out. We'll just rock that a bit. It's not how I intended it to come out, but that'll do. We'll give it a try. That doesn't appear to have made any difference. But it proves my hunch it's not the ULA, which is good news because I've got to put this one back. But on with this long drawn out saga, I'm starting to consider it could actually be bad RAM. Maybe quite a lot of it, maybe all of it. So I was assuming it can't be all the RAM chips, so I was looking for the common denominators, but maybe I'm wrong. I'm getting desperate now. It's time to start changing RAM chips. Well, we'll start in the top corner, IC24. That's not coming out for some reason. Let's check they've not bent the pins over. Oh, but they have. Loads of them. Oh, that's annoying. I've got to straighten all those up. I really don't like this sort of behaviour. This is what gets pads lifted up. Oh. Might need a bit more solder on these to get this trick to work. There we go. We'll do the ones pointing the right way first. I consider this to be yet another violation of right to repair. Fancy injuring me like this.
pigtails that need to be collected.
These chips have been a bit of a pig to get out. Just trying a bit of flux on there, so that seems to help. Just get it wiggling a bit. Get a little bit of leverage under the power supply pin.
There we go. Okay. I guess it's still early summer. They're already harvesting. That's pretty good. Year 169.
Well, I've now cleared all the RAM chips off the board, 16 of them with 16 legs. That's 256 soldered joints I've had to undo. And I've also got 16 chips off the donor board, so we should be good to put them in. Make sure I put them the right way round. And the last one's going to be a socket, for reasons I'll explain later on. I'm just going to solder a couple of pins on the top of these chips, so when I flip the board over, they don't fall out. Now I can put the last RAM chip in that socket. Just drop it back in the casing. It's a good place to put it. Plug the regulator back in. Won't work without that. Plug the monitor back in. And the diagnostic cartridge, of course. So will it work, or will I get another screen for the rubbish? So still no good. More trouble. Unbelievably, still not working, but from the sort of patterns we're seeing, sort of all new memory in, it must have something wrong with the address bus. So the 16 address lines, we'll start with address 0, A0 there, that's on pin 30 of the CPU. That goes to pin 10 of the EEPROM, which isn't connected, and also pin 2 of the multiplexer. So this is pin 30, and then we've got data. That looks okay. This is pin 10 of the EEPROM. Also good. And there's pin 2 of the multiplexer. Oh, we've got nothing. There's nothing on it. Ooh. Let's pull the power so I can do some measurements. We go from pin 30 to pin 10. We go 0 ohms. And from pin 10 to pin 2. Open. That's not right. So pin 2 goes to a via, and then from there, we're now up here. It snakes around here and goes to another via, and oh, it could be anywhere. So at this stage I'm just going to put a link wire in, just push it into the chip sockets and just sneak that in the side there. Oh, we'll try that now, see if we fixed it. Well, it's had an effect, it's different, but still not right. I think I need to sniff out more dodgy address lines. So pin 3 is address 7, that's working. So we skip one. Pin 5, that's address 1. This is address 8. This is address 2. And this is address 9. Oh, 9's bad. That's pin 39 on the CPU. And we got data there. Just not there. This is address 3. Address 10. Address 4. Address 11, not showing much there. But to be fair, address 11 on the CPU is showing the same. Address 15, there's data there. Address 12, nothing there. There's also nothing there on the CPU, so it's probably okay. Switch the power off again. So address 9 also goes to pin 24 of the EEPROM. Be a bit easier to stick a wire in there. So pin 24 and into pin 9. We'll give that a whirl. Well, that looks more positive. Oh, RAM test. It's actually doing it. Do we have a working Spectrum? I think we do. So finally got it to boot on the diagnostic cartridge. I just need to do the repair on the board. So take the power out and we can remove these little bodgy link wires. We'll need that undone and pull these out. Flip this over. I'm just going to mark that. That's pin 2 there. And there's pin 30 of the CPU there. Just got to join them together. I'm going to use this fine enamelled wire. It's used for wire wrapping normally. This is great for repairing PCB traces. You can burn the enamel off just by adding a bit of solder, although it's a bit hard to see. That should do it. So just offer that up against pin 2, warm it with the iron. That's on. Then just roughly bend it round to where we want it to go. Yeah, sort of there. Just sort of tin it there, just to bear it off. That should do. You can just give it a little bit of wiggle, just to fatigue it, and it will break off. Now I'm going to mark pin 9 and pin 39. And loosely route it like we did before. Around there, I think. Just going to put some tape over this just to hold it down. Stop it getting easily broken. Well, hopefully that's the end of all the drama on this board. Although I have got a few of the chips to put back on, haven't I? That actually includes the ROM chip, because I haven't actually tested it properly yet. It's probably alright though. And of course the joystick controller chip. We forgot about that one. There's a new one. We'll just pop a few screws back in here. I've got to quickly check the keyboard as well, so I might as well plug these in. Got these fiddly little ribbon cables, which are easily damaged. Stick some power on. It's going to do a keyboard test. That's a good start. Oh, good. Let's try number 2, colour palette test. Yep, looks alright. I'm never sure where the any key is. It's all looking pretty good. I'll try the 1 to 8K test. Memory. Good news. And of course this Spectrum has a 3-channel sound chip. Let's give that a test. If this doesn't take you back to the early days of 8-bit computing, I don't know what will. Well, that gives the computer a clean bill of health. That's good news. Just need to fix the other little bits. Oh, and test the tape deck. Well, that's that finished with. I do need to fix this big gaping hole as well. Well, that's the first copyright message I've been pleased to see. Now, I'm going to try loading a game. So just press eject, that's good. I'll get in here. This way round. There we go, tape loader. Oh, that's no good. What's going on? Fast forward. Yeah. Let's see what's wrong with the tape deck then. Actually, whilst it covers off, I might as well put this thing back in. Covers this gap up here. But to do it properly, I need to take the board out really. This has clearly had a gluing attempt done before which has failed, so I've had quite a lot of success with actually sort of melting it or welding it back together using a worn out soldering iron tip. Just sort of poke it in, stitch it along. Well, this is the underneath of the tape deck. You see the motor there. This belt looks a little bit wobbly. Oh, it's not even on straight. Okay. I don't think that's causing the issue though. I'm going to have to take the tape deck out and see what's going on with the mechanism. Something wrong with the take-up reel, I think. Just need to open the door. I should be able to wiggle it out. There we go. It's held in by the LED. It won't take a minute. You can see from this side of the tape deck, it's definitely had a drink spilled in it or something. Might have Coke or something. Scratches off. And it doesn't appear to have corroded it. Not too much. But what's going on with the mechanism? Press play. I'll just turn that by hand. There we go. Got some buzzing. You look just through that little window, I can see something hopping. Well, it doesn't make the noise with no load on it. If I just load the take-up reel up, oh, there we go. You can see that gear jumping. You can see some wear on the teeth. don't know, it seems to be just on the limit of running. You can see the teeth in this little gear are worn right on the edge, just where this is riding. So this is riding right on the top there. It's not ideal. But this has got some play in it. I wonder if the play was taken up from there and that was pushed down a bit. We might be good. I don't know if I can get this out. I'll take the belt off first. Oh, there's a little spring to unhook, if I can get it. You can just see the play in there. I just want to shim that up somehow. See if I can pull this off. Oh, I can. There we are. Just find a little washer out the drawer. See how that goes on there. Just press this back on. Just engage that in there. Just screw the pivot back in. Try and get the spring on. Fiddly little thing. Hopefully the belt stays on the pulley. There we are. Now it's running on a healthier part of the gears. That's better. So it works. Let's add a bit of load. That's better. No cogs jumping. About fast forwarding, will it fast forward? Yes it will. And rewind. A little bit of buzz in there. Let's see how it works with a tape. I'll press play. Let's run the capstan round. There we go. No rattling. Good. Fast forward. Fine. And rewind. Yeah. Making me good to try it. But I will put a new drive out on here because your one was a little bit on the slack side really. Other than the spilt drink residue, the rest looks really clean to be honest. I think it's going to be alright. The heads look really clean already, but just give me a little wipe over. Won't hurt. There's no residue coming off. That's a good sign. It's normally on this capstan you get the most mess. You thought I was going to forget to put this in, didn't you? Well, that'll show you. I don't know if there's a knack to getting this back in. Wiggling, I think. I should explain why I put a socket on this chip, and that's so I could put the old RAM chips back in one at a time and just see how many were faulty. And it turns out there are 6 faulty RAM chips. No wonder I struggled to diagnose this one. Blimey. Let's plug all this back in. And the keyboard connectors. Now just sort of scoot this in sideways. It has to find its way under the heatsink. There we go. Let's test this tape deck out now. Well, I'm calling that one fixed. I had 8 bad chips, 2 knackered traces on the PCB, and some broken plastic in the tape deck. Quite a challenge. Oh well. Catch you next time. And today in the workshop is a rather nice 1960s vintage Simpson multimeter. This is the Model 270, rather high spec. Well, this has got a lovely quality to it. Everything about it is really well made. I do like it. It looks to be 1960s vintage to me. It certainly smells old. Very nice. Well, it was made in Canada, in London, Ontario. And that's 12 volt Vids country. But there's no clues to the age of this thing. Unfortunately, this mirror deflector has fell down. I don't know if I can relocate it. Now, this lovely old thing's been sent in to me for calibration. Now, I'm not a NIST traceable calibration lab, but I can get it somewhere close. I guess the first easy thing to check is voltage. I'm going to start with the 2.5 volt range. Now, there's got a lot of sockets on here. I'm assuming it's these two for the most part. For the voltage source, I'm going to use this TTI power supply. And I'm going to compare the readings on this fairly modern multimeter. I think these go in here. The needle's slightly off zero. I'm just going to adjust it. There we go. We'll go for 1 volt. 1 volt looks pretty damn good to me. Only slightly behind. Let's try 2.5. No complaints there. Now we'll try the 10 volt scale. Let's see what 5 volts looks like. Also slightly behind. Let's try 10, full scale. That looks about right. Interesting. Let's see 50 volts. So it's a centre scale right there where it says 10. That should represent 10 volts. So that's pretty close. Now 25. Again, this is reading a little bit low. I would say that's about 24.3 volts. Difficult to say exactly on these scales. And now full scale at 50 volts. Well, it's bob on there. Let's try it at 250. For the higher voltages, I'm going to use this old Keithley power supply. This one goes up to 1200 volts. There we have 100. That's slightly below, what's that? About 95 volts it's showing. We'll go with 200 next. No, that's perfect. 250. Slightly over, but not far. And then finally 1000. At 250 volts, that's reading a little bit low as well. What's that? 238 or something? We'll go for 500. That's also under reading quite a lot. That looks to me about 475 or something. Not very good. And finally we'll try full scale with 1000 volts. It's not quite making it. There's definitely work to do on this meter. We have just spotted it's got a 5000 volt range. Well, I haven't got 5000 volts available, but we'll see what it does. And that is somewhat short again. So a few minor tweaks to make on the DC voltage ranges. We'll see how it reacts with AC. Let's change that mode on here as well. So I think we're back in this socket here. Set this to AC. And we'll go with the 250 volt range. So I connect it to an AC source, use this safe block, and oh, it's that safe I can't even get the banana plugs in. Just have to use the old-fashioned test leads like I did before. I just have to connect these crocodile clips onto the banana plugs. Nothing. Ooh, not even a twitch. We'll take it up to 100. Oh, there's a slight twitching. Ooh, how about 200? There's something very weird going on there, isn't there? Strange. Just going to knock that off. Try 1000 volt range. Power it back on. Yeah, this doesn't look good at all. It's basically not working in AC. So that can open up. Disconnect these. And put this power supply in high current mode, which is 4 amps. Set the voltage to something like 5. And the current to 1 amp. Now we need to connect both meters in series. So this goes into the current input and it comes out on here. And we'll put that into the 10 amp input there. And presumably I need it on this setting here. It says amps. Also got to set this as well, haven't I? Shift DC current. Right, let's put 1 amp through here. Oh, what's wrong? I've got it set on AC, which doesn't appear to work. There we go, DC. It's slightly overreading by about, oh, maybe 20%. Let's wind it up a bit. Take it up to 2 amps. Still overreading quite a lot. Knock that off. We'll set something like 0.1 amps. That needs to be in the other socket though. This one's slightly under. It's not far off. Now whilst that power supply is very good and it resolves down to 1 milliamp, I need to go much lower to test the 50 microamp scale. So I'm going to use this current source I built many years ago. So this current source goes from 1 microamp to 200 milliamps, and if I remember, yeah, it runs on an 18 volt supply. Yeah, left my own instructions on there. And this is one of those moments where dual power supplies come in very handy. 18 volts, probably needs a bit more current, half an amp say. Get some power. Well, the one terminal on there, the source, and this is the sink side of it. So I need to get it into the 100 microamp range. Get it down to, I don't know, 25. Should look at the measured side of it. So pull that out of there, and then we want 50 microamps there. And look at that, exactly halfway. Perfect. Let's try it down to 10. Yeah, that's pretty good. And up to, let's take it all the way, 40. Yeah, this is looking really good. And then 50 microamps there. There's nothing wrong with that scale. I'm impressed. To check the resistance measurements, I've got to put some batteries in it. That means opening it up. Brilliant. Take the leads out. Move that out of the way. Just going to undo these screws. Look, they're only finger tight. But it comes from very odd leads in the back there. Look at that. Wow. Let's get the back off. There's 4 screws in there. Flat blades as well. The worst to get off. Oh. There's no screw in there. Oh. 3 screws then. So that just lifts off then. And check out the serial number, 107. That's got to give it some sort of pedigree really, hasn't it? And we got signs of crustiness here. Let's add some leaky batteries. Probably not a surprise with the age of it. It looks like it takes a lot of batteries. I think these are AAs. So we got 1, 2, 3, 4 batteries there, and another one there. Oh. But these corroded terminals are actually brass, so I think these will clean up quite nicely. I'm sure I can do something with them. This is certainly a very pretty circuit board, very nicely made. And these resistors are beautiful. Old Wellwin, oh, nice. Some funny values there. 1.138k, 238 ohms. I'm also noticing down here this little horror show, 15 amp fuse with wire wrapped around it. It's not uncommon to find blown fuses in multimeters because accidents happen. But I think this is clearly suffering from more things like corrosion. Look at all this copper track's been sort of attacked here by the battery acid. These capacitors here for the AC coupling, there's an input called output. It's for measuring AC that's got a DC offset, like the output of an amplifier for example. Oh, look at that. There's a lot of corrosion there, a lot of damage. This definitely needs addressing. I'm not going to put batteries in it at this stage because terminals are all corroded, so I'm going to use the power supply, set this to 6 volts to represent the 4 batteries, and this one will be 1.5 volts. Let's connect the negative terminal to this wire, and our 6-volt positive on here, and put our 1.5 volts where this battery goes. Let's turn them on and connect these leads now, which go into this decade resistance box. Just going to set this to 0 ohms to calibrate the meter. Just going to zero that now. Set to 10 ohms. That's pretty good, that is. Not far off at all. 20, 30, 40, 50. Yeah, it's not far off at all on this scale. Try the times 100 scale. 200 ohms. That looks bob on to me. 500. 1500. This is working very nicely. 5 kilo ohms. Yes, looking good. 15 kilo ohms. Nothing wrong here. Then the top scale, resistance times 10,000. Just set all these back to 0. Well, set 10k. Perfect. 20, 30, 40, 50, 150, 250, then we'll go for 500. Nothing really wrong with the resistance measurements, just need to clean up the battery terminals, but I'll need to deal with what's wrong with the AC voltage measurement. Pull these wires out. There's little grub screws in the back of these knobs, just going to undo those so I can just lift them off. Some of these nuts here, I suspect these are actually to the meter itself. Couple little screws to take out, nice and short. Just need to mark these shafts up with their orientation. Don't want to get that mixed up. I think I'm going to have to unsolder this wire, so that's stopping it lift off. I'm getting enough heat in there. Then this green wire on here, it's my next sort of restriction. I think I can actually just pull this battery clip off. There we go. Now that should lift off. There we go. Here we can see the damage that the leak battery's done. It's previously been repaired. Look, there's this link wire. It's quite long to go over this little break here. And I'm wondering if there's another one here. You can only know by trying to clean it up. I've just noticed these diodes have been replaced. They've been tacked on from the top, which I don't blame him for doing that. But those are very old diodes. So this thing's been blown up and repaired a long time ago. Which gives a few more clues about the age of this multimeter. See if I can get this corroded battery terminal out. Not sure if I can. It's fighting me all the way. There we are. Let's look at all these salts that are deposited here. That one came out easier. So this terminal here so I can get that out easily. Yes. Let's see if I can get some of this corrosion off by putting these in some oxalic acid. We'll see how it works. Just want to remove the cover off the meter face, which is held in from the back by 4 screws. Now that's revealed the meter movements. We'll have to deal with this mirrored face that's not in the right place. So I'm going to take this out, which are these 2 screws here. I'm not sure what that smudge is, but I might gently try and clean that off, but we'll see. I don't want to ruin this face. It's pretty old, I reckon. But this was originally stuck on with this sticky tape, which is barely tacky anymore. So this should just lift off. Oh, but I'll be honest. It stuck better than I thought it would be. I'm going to try some hot air on it. See if I can soften this adhesive. That's left this sticky residue, which is actually very sticky, but I think it needs to come off. I'll see if it wipes off with some isopropyl alcohol. Maybe it will. I'd say that slightly is softening it, not really cleaning it off very well. Actually, I've got this label remover spray. Barely works. There we go. See if that's actually moving it. Oh, that's better. Yes. That's cleaned up really nicely. Oh, you can see yourselves in it. I don't think this can stay on. It's all lifted, it's not going to be the right thing. I don't want to damage this either. Be very careful. I think I'm going to see how I get on just peeling this up. Just trying to pick this lot up. It's coming up in little pieces. It's too well stuck down to peel off in one go. Actually, now I've cleaned that up a bit, it's all very sticky. I think I'm just going to plonk it back on. Well, that's honestly on there quite strongly, and that definitely looks a lot better. See if I can clean that off. I'm going to start off with a cotton swab with water on it. You never know your luck. And it looks like we are lucky. There's more of it over here now, I've spotted it. There doesn't appear to be anything wrong with this movement, so I'm not going to mess with it. Instead, I'm just going to slide the meter face back underneath. Very carefully try and line this screw up. There's quite a lot of muck and grease on the lens, and some of it's on the inside. I assume these are just little end stops to stop the needle sort of going too far. But they're fine. It allows full travel of the movement. So you can put the bezel back on. It's looking better already. This screw and washer's a little bit crusty and manky. I'm going to see if I can clean it up. That's a bit better. You can actually see the washers separate to it now. See if I can clean some of this up. A lot of it will just scrape off, I reckon. Once I've got most of it off. See what else I can do with it. This battery contact's completely gone. I think it's supposed to be the same as this one. So I'm going to see if I can make another one. It's about that thick. Draw a line there. Whilst the chemicals are doing their thing, I need to deal with this corrosion on here. You don't see many pots like these, I have to say, because of the construction. So the wipers sort of go around the side of this thing. Very nice. However, I want to clean this corrosion up without ruining the carbon track. Be a good idea to measure this before I do anything to it. About 470 odd ohms. I'll start by trying to brush it off with a wire brush. Get all the loose bits off. This is actually very deep corrosion on here. I'll see if I can get it off with a bit more oxalic acid. But I don't want to get it on the inside, definitely not. See if I can scrape some of this corrosion off the tracks. See what's left underneath them as well. Just using a bit of dilute hydrochloric acid on this one, just to eat this green corrosion away. And there's more corrosion under this resistor. I think it's a resistor. So I can unsolder it from there. There we go. Pull this sleeve off, see what it is. Oh yes, definitely. That's a wire wound resistor, without a doubt. Nothing wrong with it. Put the lid back on. Got some more corrosion here. See what I can scrape off. See if I can eat some of this corrosion away again. And it's even worse on the back of the board. Loads of corrosion. I'm going to remove this old repair. Looks a bit untidy. It's actually in my way. Again with a bit of dilute acid, clean off all this old corrosion. See if I can brighten this whole thing up a bit. See if I can remove this corroded dead solder, because it goes quite hard. And you can see the old corroded stuff there lifting off. It's just letting the flux really do its work on there, get some heat into it. And hopefully clean up this copper. Well, underneath that corrosion turned out to be quite a lot of missing copper, so no wonder it's reading a bit funny. So now time to repair the tracks. I'm going to add a little bit of flux onto it. Try and get the solder to sort of retake. And just tin the whole thing. I'm going to take a piece of tin copper wire, just put it over where it should sit, where the gap is. Same on this side. Just snip half an inch of wire off and place it over the gap, just as before. Try and make it straight, Mark. Put the sleeve back over this resistor. I'm not sure when I knocked it off, but I clearly did. I've just noticed the other end of that resistor. The solder's all crunchy on there as well. We know the drill. Get some heat into it. Plenty of flux. And the crusty bits should break off. There we are. Put this resistor back in. Solder it up. Now to fix these tracks, put the flux on like before. Then put the fresh solder on. Tin the whole thing. Let's just lay some pre-formed wire on there. Tack it down over here. And just fill it in as we go. Just wash all this flux off. Not that it's a problem, it's just very sticky and messy. This is the bottom of the range selector switch. Now I don't think there's anything wrong with it in particular, but I'm going to give it a bit of a clean. It's another source of error. Actually, there's another layer underneath. It's a bit harder to get at. Same story on the top. And same goes for the function select switch. And now it's time to replate the battery connections. So I've got the two new ones I made and the old ones have been cleaned up as best as I can and degreased. I've got a big lump of nickel there, that's the anode. Put that in the plating solution. On a plate with about 2.4 volts, 70 milliamps. Just thread this piece of wire through that hole so I can just dangle it in the solution. And the negative lead is connected to the part I'm plating. Look at that, beautiful. Just give that a rinse off. Oh. And the next one. Just going to slightly agitate this. But it looks done. Rinse it off as well. Okay. So another one done. Now for the corner terminals. Try not to drop them in. Seeing that current rise again, always a good sign. It's a good idea to limit the current to something sensible. For nickel plating it's about 100 milliamps per square inch. Any higher than that you get a bit of a flaky, grainy deposit. It's not what you want. That's that one done. And now the last part. I'm going to put this potentiometer back on. Requires quite a lot of solder, this. That'll do. I think I'm going to replace this capacitor as well. It's pretty old and it's probably paper and wax. Feels sticky anyway. I'm going to fit this instead, same value and comparable physical size, so should be good. And still the insulation off these leads though. probably a good time to change this dodgy fuse. Just put a nice new 1 amp fuse in, like it's supposed to have. Now this should line up. Yes, it does. Pop a screw in. And this other one. I'm going to put the meter connections on. It's got these 2 washers on there. And then these nuts. Got to heat up the input terminal again. There we go, that's the lead in. Put the positive battery terminal back in. This one was okay, I think. Just push it down. There we go. Then our replated corner piece there. Nice. Same on this side. Okay. Just going to unsolder this one because this one's completely shot. Might apply a bit more solder. Get the heat to transfer. There we go. Put the new battery terminal in. Homemade. Pop the black wire in the hole. Just add a bit of solder. And finally this one here. Just got to get both these green wires in. There's one. There we go. Just going to screw the knobs back on. Hopefully they're in the right position. Range selector should be set on 500 milliamps. And the Ohm Zero knob doesn't have any point on it, so it doesn't matter which way it goes. Now it should be ready for calibration. I found this schematic on a website called Simpson260.com. Very useful, but it doesn't have a great deal about the Simpson 270. But to be honest, I think it's exactly the same, just higher spec components. And it does give a hint about calibration here. It tells you to calibrate this resistor and the meter itself to be 5 kilo ohms across the pair. You also have to be careful about little notes on schematics like this. It tells you to make sure the switches are shown in the minus 1000 volt DC position. So minus DC, 1000 volts. So go from a meter positive terminal. And the other side of this potentiometer R27 is just in there. And we measure in 5.2 kilo ohms. It's quite a bit over. Just going to wind that up down. Oh. There we go. So our biggest problem was the AC scale, set on 250 volts. Well, that's supposed to be nearly 100 volts. Nowhere near. The fact that that needle's slightly wandering around, and I remember it was properly twitching before I stripped it down, I think we got some component breakdown. And there's not many components in here. We said the AC measurement is on position C for this function switch here. Now from here it goes to the bottom of these resistor networks here. Interestingly, there's 2 places to adjust this, R28 and R31. Not quite sure what the difference is, must be subtle. But we have the 2 diodes here, D1 and D2. And I do recall they've already been replaced and they look really old. These will be germanium diodes, and they're so cheap to replace now, I'm just going to change them. I assume the red end refers to the anode. I'm just going to put very standard 1N4007s in. Look at that result. So at least one of those diodes was bad. I'll just turn it up to 200. Okay, so this scale's overreading slightly. I'll twiddle those pots. There's another adjustment to make here for the 10 amp scale. And if you can just make out there's this piece of wire going from the 10 amp positive to negative scale, and just attached to it is this little nut, and you slide this along there to calibrate it. So I'll set this into the 10 amp scale. One lead in there, one in there. It is reading a little bit under. Just going to do a quick test of each range. Start with 2.5 volt range. I've got this set at 2 volts and that's perfect. 10 volt range, very close. We'll wind it up to 5 volts. There we go, pretty close. 8 volts, yeah, that's good. Then a 50 volt range, stick it on to 10 volts. Nice. 20 volts, let me get there. Yep. 30 volts. A little bit off, but not really adjustable, I'm afraid. This is as good as it gets. 40 volts. To be fair, I think this is fit for purpose, really. Check the current range. 500 milliamps. That's full scale. 250 milliamps. Not bad. Now 50 milliamps. Pretty good that. Try that on the 100 milliamp scale. Pretty close to the middle, pretty good. 5 milliamps. Okay. Now to check out the battery connections. Big battery requires the lid on to secure it, I think. There we go. Oh, wrong way round. Now connect the resistor box back in. 1 ohm scale. Adjust the 0. 10 ohms, 20, 30, 40, 50. Looking good. 1k, 2k, 3k, 4k. Lovely. Finally, 10,000. 10k, 20k, 30k, 40k, 50k, 150, 250, 500. Looks pretty good to me. Put it back in its case. Let's not forget to pack the vintage 1960s crop clips in. Wow, you don't see those every day. Plus the old vintage meter leads, clothes probes. I've never seen them so small and stubby. So there we are. There's a nice working example of a Simpson 270 meter. Not exactly sure the age, but definitely 60s. Just look at that. I don't often get old multimeters in for repair, and I quite enjoyed fixing this one. And if you're interested in learning more about fixing vintage electronics, check out the Mend It Like Mark community. The links are in the description below. Catch you next time.